Hi everyone and welcome back. So we're taking a look now at day 2 on the applications of matrices. So we're still working with those 3x4 matrices, okay? So let's go through the first question we have here, another application problem. You work at a fruit stand that sells apples for $2 per pound, so apples are $2 per pound, oranges are $5 per pound, and bananas are $3 per pound. Yesterday, you sold 60 pounds of fruit and made $180. You sold 10 more pounds of apples than bananas. How many pounds of each fruit did you sell? Okay. Well, first I'm going to come up with my let statement, so let's do that first. All right, so there are my let statements. So X is pounds of apples, Y is pounds of oranges, and Z is pounds of bananas. So we want to come up with our system of equations. We know that each apple, orange, and banana sold total to 60 pounds. So we know, again, each apple, banana, oranges sold, it total to 60 pounds. So we have X plus Y plus Z is equal to 60. Now we know that an apple was $2 per pound, so I have 2X plus an orange was $5 per pound. So I have plus 5y plus bananas were $3 per pound. So plus 3z total to the amount of money, which ended up being $180. All right, so our first equation was merely talking about X amount of pounds plus Y amount of pounds plus Z amount of pounds for the amount of apples, oranges, and bananas sold. And then 2X plus 5Y plus 3Z equaling 180 is all dealing with money. All right, that last piece now that we have is you sold 10 pounds more of apples than bananas. So you sold 10 more pounds of apples than you did bananas. All right, so here are my 3 equations. Now we want to get these set up so we can create our augmented matrix. So I'm going to subtract over my Z, and this is going to look like X plus 0y minus Z equals 10. All right, so now let's come up with our augmented matrix. So we're just going to rewrite these as our augmented matrix. All right, so our augmented matrix is going to look like I have 1, 1, 1, 60. I have 2, 5, 3, 180. And I have 1, 0, negative 1, 10. So now remember the goal for the augmented matrix. When I have a 3x4, we want to get this into just row echelon form. All right? So that looks like this. I have 1s along the main diagonal. My answers are on the right-hand side. I have 0s here, and I have numbers everywhere else. Now, when you take a look at your Delta Math homework, it is going to ask you to write it in reduced row echelon form. You can bypass that and just send me your responses. So just copy down the question and then send it to me on paper. Because like I said, reduced row echelon form are 3 to 4 extra steps than this already is. For example, this question ends up being 7 steps. All right, so when you look at your Delta Math homework, you guys can send me those questions, do them by hand, and just get it into row echelon form. All right, you can disregard it saying reduced. All right, so I'm going to clean up everything that we have here just to give us some space because, like I said, this is going to be 7 steps. All right, so make sure you have this written down. All right, so let's start off with the first piece. So this is actually already a 1, so we're good. That piece is done. Now, next, we want to turn this into a 0 right here. So we want to turn that 2 into a 0. And the way that we're going to do that is I'm going to use the first row. So I'm going to multiply the first row by something, add it to the second row to get my new second row. All right? So I'm going to multiply that first row by negative 2. Because if I multiply it by negative 2, you'll see that those 2's will cancel out and become 0. All right? And nothing changes about the second row. And now I'm just going to combine like terms. This will be 0. This will be 3, this will be 1, and this will be 60. So here is my new second row. All right, so let's write it out. Again, nothing changed with the first row. The second row is now 0, 3, 1, 60. And my third row, nothing changed. We didn't do anything to it either. Okay, so now I can check that off. All right, next piece. We now want to turn this into a 0. So that's the next piece. Well, we need to adjust row 3. Row 3 needs to change this into a 0. So how are we going to do that? Well, we need to multiply the first row by something, add it to the third row to get my new third row. So what should I multiply the first row by? Good, -1. So now I'll have -1, -1, -1, -60, and I'm adding that to my third row. We'll end up getting 0, which is what we wanted, -1, -2, and -50. So there is my new third row. Okay, so let's write that out. Again, nothing changed about the first row. Nothing changed about the second row. But the third row, we now have 0, -1, -2, and -50. So we took care of that 0 now. Awesome. All right, what do we want to do next? Well, it's probably going to be a little easier for us if we actually now switch the second and third row. Because I want this number in the middle, so my second row, second column element, I want that to become a 1. So let's first switch row 2 and row 3. So we're going to write switch row 2 and row 3. So let's do that here. Leave the first row. And now I'm going to switch. I have 0, -1, -2, -50. And I have 0, 3, 1, 60. Because now that's a lot easier to make this number a positive 1. All we got to do now is multiply the second row by -1 to get our new second row. And that's going to satisfy turning this piece right here into a 1. All right, so let's do it. We're going to multiply everything by -1. So we'll end up with nothing happens to the first row. I'll have 0, 1, 2, 50, and nothing happened to the third row. All right, so far so good. Now for my next step, I want to turn this into a 0. So remember, we want to turn this into a 0, okay? So now the only way that I'm going to be able to do that is we need to multiply the second row by something. So that way when I add it to the third row, I'll get my new third row. And what we need to multiply the second row by is -3. So let's see what happens. We'll have 0, -3, -6, -150. And I'll have 0, 3, 1, and 60. We're just adding them together. We'll have 0, 0, -5, -90. So now here is my new third row, which is exactly what we wanted. So let's write it out. We have 1, 1, 1, 60. Nothing changed about the second row. And now my third row, I have 0, 0, -5, -90. Awesome, this is looking great so far. So we can check this off now. We got that to be a 0. And now the last thing we need to do is to change this into a 1. We need to change that element to a 1. So the way we're going to change this element into a 1 is if we just multiply the third row by -1/5. Okay, so if I multiply the third row by -1/5, I'll get my new third row. And this -5 will become a 1. So let's do it. Nothing changed about the first row. Nothing changed about the second row. When I multiply this bottom row by -1/5, I'll be left with a 1 here. And -90 times -1/5 is 18. So there you have it. This is now in row echelon form. Pay attention here how we have the main diagonals are a 1. And I have my zeros here and my numbers are everywhere else. Okay? So let's actually solve this. All right, now I'm going to clean up what I have here just to make some room that we were able to solve this. So make sure you have what's written, and I'm going to erase some space here, all right? That way we can solve for x, y, and z, okay? So if we look, we actually already know what z is. We know z is equal to 18. All right, let's just do this line by line. Here, I'll have y plus 2z is equal to 50. Y plus 2 times 18 is equal to 50. Well, this is just 36. So when I subtract over the 36, I'll get y to equal 14. So far I have z equals 18, y equals 14. And now let's solve for x using this line. We have x plus y plus z equals 60. We don't know what x is, but we know y is 14 and z is 18, which is all equal to 60. We'll have x plus 32 is equal to 60. Subtract over the 32, and you'll get x to equal 28. So there you have it. We have x equals 28. So we have x equals 28. Y equals 14, and z equals 18. Again, if you were asked to plot this point, which I'm not going to ask you to, but we're looking actually in the three-dimensional plane, so that would be a point on the three-dimensional plane, okay? And to answer our question, that was 28 pounds of apples, 14 pounds of oranges, and 18 pounds of bananas. All right, so hopefully this question helped and cleared up some information here on solving these 3x4 systems. All right, so let's take a look at question number 2. Again, the goal for all of these systems is to get them into row echelon form. When we deal with the 2x2s, we get those in reduced row echelon form. But when I'm dealing with a 3x3, which in the end result is really we're looking at a 3x4, because we have that fourth column is the constant matrix. We want to get that in row echelon form just to minimize our steps. All right, so let's begin. For question 2, we have a theater group sold 440 tickets for $3,940. We have each regular ticket cost $5, each premium ticket costs $15, and each elite ticket costs $25. All right, so we should probably highlight over some important information here so far. So we have, they sold a total of 440 tickets. We have $3,940 was made. Each regular ticket was $5. The premium was $15, and the elite was $25. All right, we have the number of regular tickets sold was 3 times the amount of premium and elite tickets combined. How many of each type? So we want to know how many of each type of ticket was sold. All right, so let's come up with our let statements. All right, so this is what I'm going to let x, y, and z be equal to. So let's actually come up with our first equation. So we know we had x number of regular tickets, y number of premium tickets, and z number of elite tickets were all sold in total as 440 tickets. Now we know the cost of a regular ticket was $5. The cost of the premium was $15, and then the cost of the elite was $25. And in the end, this theater group sold $3,940 worth of tickets. Okay? All right, now our last piece here of information is that regular tickets, so regular tickets is X, sold 3 times the number of premium and elite. So 3 times the number of premium and elite tickets. So there you have it. Those are our system of equations. Now we want to get this last equation into a better form. We want this written as x equals, so first let me distribute. And now we're going to bring over the 3y and bring over the 3z. So we'll be looking at x minus 3y minus 3z equals 0. Because we want all of our x's lined up, the y's, and then the z's. All right, so let's come up with our augmented matrix. Our augmented matrix is going to look like 1, 1, 1, 440, 5, 15, 25, 3,940, and then 1, -3, -3, 0. All right, so there's our augmented matrix. Remember the goal. Keep that goal in mind to get this in row echelon form. So let's clean this up a bit so we can start with our steps. Okay, so first things first, again, we got to keep that goal in mind. We want this in row echelon form, where we have ones along the main diagonal. We have zeros here, here, and here, and these are just whatever number or constants that we find. Okay, so keep that goal in mind. So first things first, I actually already see that this is already a 1, so we can check that off. That's good. Now, next thing we want to do is I want to turn now this 5 into a 0. So the way we're going to turn that 5 into a 0, and you can pick either or. I'm going to go with using the first row to turn that into a 0. So I'm going to utilize the first row and the second row to turn this 5 into a 0. So we're going to multiply the first row by -5 and add it to the second row to get my new second row. Okay? So let's see. We'll have -5, -5, -5, and -5 times 440 is -2,200. So that's -2,200. And I'm just adding that with my second row. Okay. Well, when we add our rows together, we'll get 0, which is what we wanted here, 10, 20, and -2,200 plus 3,940 ends up being 1,740. Okay, so now here is my new second row. So this took care of making this a 0. So let's write it out. Awesome. Okay, now the next thing I want to do is I want to turn this 1 into a 0. So we're going to make that 1 turn into a 0. So the way I'm going to make that 1 turn into a 0 is I'm going to multiply the first row by something, add it with the third row to get my new third row. All right, well, I need to multiply the first row by -1. So I'll have -1, -1, -1, -440. And I'm adding that with 1, -3, -3, and 0. So I'll have a 0 here, which is what I wanted. -4, -4, and -440. Awesome. Okay, so now that's my new third row. So let's write it out. So we just took care of that. We made that a 0. So now if I look, nothing changed about the first row. Nothing changed about the second row. But now my third row is 0, -4, -4, and -440. Awesome. All right, let's keep going. Next thing I want to do now is change this 10 into a 1. So how am I going to turn that 10 into a 1? Well, this part's actually nice. I'm just going to multiply this entire second row by 1/10 to get my new second row. So let's do it. Multiply the entire second row by 1/10. Again, nothing changes with the first row. So I'll have 1, 1, 1 by 440. Now I'll have 0, 1, 2, and 1740 divided by 10 is just 174. And that third row stays as it was. Okay? So now we can check off that we took care of making this value here. We took care of this and making it a 1. So that's good. Okay, the next thing I want to take a look at is I want to make this -4 turn into a 0. And the way that I'm going to turn that into a 0 is by utilizing the second row and combining it with the third row. So I'm going to utilize the second row, combine it with the third row to get my new third row. I'm going to multiply the second row by +4. So if I have 0, 4, 8, And 174 times 4 is 696. And I'm keeping the third row as is, so that way I can come up with my new third row. All right, so when I combine like terms, that's just 0. That's just 0, which is what we wanted. This is 4. And 696 minus 440 is 256. Okay, so now here is my new third row. Awesome, we're getting so close, guys. So I have my 111, 440. I have 012, 174. And then I've got 004, 256. Awesome, because there's my new third row. Very last thing that we have to do is change this 4 into a 1. We got to make it a 1. Okay? So this actually is nice and easy. To make that 4 turn into a 1, we're just going to multiply this entire third row by 1/4 to get my new third row. All right, so let's write it out. I have got 111. I got my 440. Nothing changed with the second row. And now my new third row, I'll have a 1 here. And 1/4 times 256 ends up being 64. So this is just 64 now. All right, guys, we did it. We have 1s along the main diagonal. That's what we wanted. We have our 0s here. And the numbers everywhere else. Awesome. Perfect. So now we can solve for x, y, and z. All right, well, we know z is going to equal 64. We can solve for y. So I have y plus 2z is equal to 174. I have y plus 2 times 64 is equal to 174. All right. Now, 2 times 64 is 128. So really, I'm subtracting 128 on both sides. And I end up getting y equals, well, 174 minus 128 is 46. So I've got y, I've got z. Now I just need to solve for x. So let's write this out. We have x plus y is 46 plus z, which is 64, equals 440. I'll have x plus 46 plus 64 is 110, which equals that 440. When I subtract over 110, we'll get x equals 330. So there you guys have it. I have 330, comma 46, comma 64. There's my final answer. So we know 330 regular tickets were sold. There were 46 premium tickets sold and 64 elite tickets sold. All right, so questions 3 and 4, I want to show you guys how to do this on the TI-89 calculator. So I'm actually going to post a separate video on that because I think this is just an extremely useful and helpful tool for you guys. It will save you a lot of time. Like I said, if you do end up deciding to take a class like this in college, usually college classes may permit a calculator. I don't know. But if they do, you'll actually know how to type this stuff in and get an answer fairly quickly without having to do all these steps. All right, so I hope you guys found this video helpful. Stay tuned. There is going to be another one shortly just to show you how to do this all in the calculator. All right, I'll talk to you guys soon.